Hi guys, it's Thursday afternoon and you should be taking out Wednesday's homework. Okay, so I'll wait a minute, take it out. Let's go, Josh, get the homework out. Still waiting. Okay, that's it, time's up. So let's go. If you don't have it out, someone get up, press pause until everyone has it out. Okay, so you have a circular shield. So we're talking about a circle. It's heated over fire. Its radius is going to increase. So here's its radius. The radius increases at a rate of 1/5 centimeters per second. So the radius increasing is going to be dr over dt, and that's going to equal 1/5. And the 1/5 is positive because it's increasing. If they said that it was getting smaller, then you would do a negative 1/5. At what rate, so that's our find, is the shield's area increasing? So find dA over dt when the radius equals 50. Okay, so if we want to find dA over dt, that means we have to start with the area. So the area of a circle is pi r squared, and we're going to take the derivative of that. So we're going to get dA over dt equals 2 pi r dr over dt. And then we're going to substitute. Well, dA over dt is what we're looking for. R is 50, and dr over dt is 1/5. Okay, so if we work this all out, 2 times 50 is 100. And then you can see that 5 will go into 120 times. And we're going to get 20 pi, and for the units, it's going to be centimeters per second, but this is about the area, so area is always squared. So this would be your final answer. Okay, so now we're going to move on to the sheet that I gave you. On the top it says Kuta Software Infinite Calculus Related Rates. All right, so take that out. It's the sheet that has 3 problems on it. So start looking for that one. Okay, if it's taking you guys too long to get it out, press pause and then come back. Okay, so for this one, water is leaking onto a floor, forming a circular pool. So we're talking about a circle. The radius of the pool increases. So dr over dt equals... Sorry, that was my phone. Okay, so the radius of the pool is increasing at a rate of 4. Okay, how fast, that's the find. How fast is the area of the pool increasing? So find dA over dt. Okay, sorry about that. How fast is the area? So, okay, find dA over dt when the radius equals 5. This is just like the homework problem. Okay, so we're going to start with area. Area equals pi r squared. Find the derivative of both sides like we did before. And now substitute. So we're looking for dA over dt. R is 5, and dr over dt is 4. So 2 times 5 is 10. 10 times 4 is 40. So you can have 40 pi. And the units are going to be centimeters per minute, and it's about area, so therefore it's squared. Okay, so that was number 1, and actually I just realized I should have waited for you to try to work that one out, but that's okay. So now comes number 2. So since you just got, I'm thinking you already had this sheet. So for number 2, someone should press pause on this while you guys work, maybe time it for like 10 minutes, and then come back for the solution. So press pause now. Okay, number 2. So there's oil spilling. Again, we have a circle. The area increases. So it's dA over dt at a rate of 9 pi. How fast, that's your find, is the radius increasing? So we're going to look for dr over dt when the radius equals 10. So again, we're going to start with the area equals pi r squared. Take the derivative of both sides. And now we're going to substitute. So dA over dt is 9 pi. R is 10. And we're looking for dr over dt. Okay, 2 times 10 is 20. I'm going to go over here, and then we're going to divide both sides by 20 pi. And of course, you can cancel those pi's, and you will end up getting 9 over 20. And this is meters per minute. Okay, but it's just the radius that is that we're talking about, so it's not squared or anything like that, and that would be your dr over dt. Okay, and there's one more problem. Now we're going to try a cone for the first time. This one is way more complicated. So you're going to read this and try it. Try for about 10 minutes. Put this on pause and then come back. Okay, are you back already? Has Josh been doing anything at all? Someone please tell me. Okay, number 3. So we have a cone. Okay, so I'm going to kind of draw the cone just so you can get a better idea. And it is 10 centimeters tall, and the radius is also 10. This is going to be very important to the story later on. The cup is being filled with water so that the water level rises at a rate of 2. So as the water level rises, think about this cone filling up. Isn't that how the height is changing? So your dH over dt is going to be 2. Okay, at what rate, so that's your fine, at what rate is water being poured into the cup? So when you're pouring water into a cup, we're talking definitely about volume, like when you're filling a pool. So find dV over dt when the water level, so that's the height, is equal to 8. Okay, so this is our goal. So first of all, in order to get dV over dt, you're going to need a volume to start with, and the volume formula for a volume of a cone is 1/3 pi r squared h. Okay, so they used to always give you that formula with the AP test if necessary. I mean, I can't swear that they're going to do it again this year, but they always did in the past. Okay, so we're going to run into trouble, so don't copy this unless you want to copy it just so you can see why you couldn't do it. Okay, so we take the derivative of both sides. So we get dV over dt equals, and now you have two variables, so you're going to have to do a product rule. So it's going to be this thing times this thing. So it's going to be the first times the derivative of the second plus the second times the derivative of the first. Okay, and here's where we run into trouble, because we're going to need dV over dt. Well, that's what we're supposed to find, so that's okay, we don't know that. We need an R. We have no R right now because we're only given this when h equals 8. We need a dH over dt, which we do have. It's up there. Now, I just want to stop for a minute. You might be saying, why can't I use 10 as my radius? And you can't, because it's just saying that that's how big the cone is. But we're interested in the rate when the height is 8, not when it's 10. Okay. And then we need a h here, so that's going to be 8. Our r is still unknown, but the most important part here is we need dr over dt. And there's no way we could get dr over dt. So we're going to have to start from scratch. And you will find that you will have to do this over and over again with related rates, just like you do with a lot of stuff that has to do with calculus. We need a different plan, because using the product rule is not going to work for us. So let's start over. So the volume is, now start copying, is 1/3 pi r squared h. Anytime you need to, just press pause so people can start getting caught up. Okay, so here's why those 10s for the over here are so important. The radius is 10 and the height is 10. That means that the ratio of the height to the radius is 10 to 10, which is 1 to 1. So whatever the radius is, the height is going to be. So if the height is 8, that means that the radius is going to be 8. Now you might say, so then go back and use the product rule, but we still have no way to get dr over dt. Okay, so what we have to do is we need to get rid of the r. So how are we going to get rid of the r? Well, why don't we take one of these values here and put it into the formula so we only have one variable in there. Now, if I take my, if I take h, so I know r and h are the same. I can't put 8 in there yet because I didn't take the derivative. I can only put those in after I take the derivative. So if I decide, don't copy this part, I mean unless you want to. If I decide to change h to r, because h and r are the same, I'm going to get this. Now when I take the derivative, I'm going to get this. And now notice I have no dh over dt, and I know something about dh over dt, so I need an h in there. And I don't know what dr over dt is, so we substituted incorrectly. So we're going to erase that, and we're going to substitute and make it all h's instead of r's. So I did not take the derivative yet. So all I'm doing is I'm using this fact that h and r are the same, and I'm putting in h for this r right here. Okay? So I can simplify. Okay, and this is going to be something that's going to work for us. Okay, and I just want to mention one more time, you cannot put the 8's in until after you take the derivative. And when you do this line over here and you do the substitution, that is not taking the derivative, it's just substituting. Okay, now we're going to take the derivative. So we get dv over dt equals, we're going to use the power rule, so it's going to be 3 times 1/3, which is just going to be 1, pi h squared dh over dt. Okay, so let's start substituting. dv over dt is what we're looking for. We have pi, h is 8, and dh over dt is 2. So we get pi times 64 times 2. So this is going to be 128 pi centimeters. So now for the units, the question is saying at what rate is water being poured? That's volume, and volume is always cubed per second. Sorry. Okay, sorry about that. The phone rang. I'm extremely popular this evening for some reason. That was JoJo. Oh my God, it's the famous JoJo. The dog makes so much noise. I'm sorry. Okay, so that's it. So, am I giving you homework? Yes. So what I'm going to do is I'm going to give you homework, and then... Okay, so we're not going to have homework for Thursday night, but we will definitely have homework for Friday night. Okay, so that's it. Bye.